Okay, so hi everyone, I'm Videsh. I'll be making a demo video for a data warehouse use case and sample application. I'll be sharing the GitHub links and the link of this video to all of you so you can review it later as well. Okay, so for the first case study, I'll briefly explain the use case to all of you. So the use case is basically a ticket resolution system. So let's say there's a business which performs customer support, which provides customer support for a company. So every now and then there will be a customer who wants to file a complaint, so they'll raise a ticket, right? So once they raise a ticket, uh, the company will guarantee that, okay, let's say a customer raises a ticket related to performance issues. So for those kinds of tickets, the company guarantees that we will resolve any such issue within 3 hours. Now when they receive the ticket and they process the ticket and finally resolve the ticket, they'll also track how long did it actually take them to arrive at a resolution. Now using that number, that time duration and their uh, quoted time duration for resolution, which is called as a service level agreement, so SLA. So they have made an agreement that they'll resolve the ticket within 3 hours, but let's say they're taking 200 minutes, so more than 3 hours, right? So they are breaching their SLA. On the other hand, if they manage to resolve the ticket within like an hour or so, they have met their SLA. So they have met their level agreement which they have made. So this is what that data kind of looks like. I'll quickly show you the actual table itself. Yeah, so like let's say for the issue type billing, they've have had four queries and they've met the SLA on all four of those tickets. So 100% SLA compliance. And if you go to the fact table here, so we have a ticket ID here. So let's say T3, SLA of 720 minutes, and they've resolved the ticket within 108 minutes. Whereas on the other hand, let's see, yeah. So for an issue key of 5, they say that they'll meet an SLA of 240 minutes, but they have not managed to resolve this ticket at all. So they have not met the SLA and so on. So here also, if you see, for issue key 3, the SLA target was 120 minutes. However, they took 187 minutes to resolve it, hence they did not meet the SLA. So we'll be looking at a data warehouse application for this use case next. So this is the core idea behind a data lakehouse. So you have your data sources. Your data might be coming in through some batch processing jobs or through a stream of data. Once the data enters your pipeline, it is first stored in the bronze layer. So bronze layer contains tables which store raw data from your data sources. Once you take this raw data and apply some filters, some augmentations, very basic transformations and processing over this data, you move it to what's called the silver layer. So the silver layer has your clean data, so to speak. Now, depending on the use case, different clients or different stakeholders can use data from the silver table or the silver layer to build the gold layer. So the gold layer has gold tables, and these gold tables are often the result of complicated business level logics, aggregations, joins performed on tables residing in the silver layer. These gold tables are then used by end users to perform business intelligence, business analytics, and also for machine learning tasks. Moving on. Okay, so now we'll be going over how to run the application. So once you clone the GitHub repository, you'll find two directories inside it. One is the support analytics lakehouse, and one is the customer support lakehouse. I'll just close some of these tabs here. Yeah. So once you go to the support analytics lakehouse directory, you'll find the first application here. I have included the requirements file as well, so you can set up a virtual environment in Python and run pip to install all these dependencies. Once you have that set up, you should create an environment file which looks something like this. I'll be going over how you can set up Metabase email and password credentials as well. So I have a Docker file here. You should have Docker installed. It just makes running the entire project easier. So I have Docker running here. I'll just go back to my terminal. I'm inside the support analytics lakehouse directory and I run docker compose -d. So when you run this command for the first time, it will take some time because it will download the respective images for Postgres and Metabase to set up the services. And once you have it running, you will be able to see it here through Docker PS. So we can see there are three things running. So one is the entire application setup here, support analytics lakehouse app, one component of which is Metabase, and one of them is Postgres. So for this demo, I'll be using Postgres database to simulate the bronze, silver, and gold layers through SQL tables. Okay, so before proceeding, I would like to go over the project structure as well. So in the SQL directory, you can find various SQL queries which I'm using to perform either transformations, aggregations, or business level logic to create the goal tables or to find out what are the key performance indexes later on. There is also a data directory which contains sample data. It also contains what you can call as bronze and silver data. So this data is basically wha- the actual data which is being stored in the Postgres database later on. So these data files are stored in a format called Parquet. So it's another data format, just like CSV or Excel, let's say. It's a different data format which I'm using to store data. All right, and finally coming to the app directory, there is a config file. So here you can configure all your environment variables. So if you do not wish to use an environment variable, you can provide the value directly here as well. All right. There are also a lot of different files, and for the purposes of this demo, I won't be explaining the code logic behind all of them. But if you go through them, they're all really small and simple files. So like something like generating random data in beginning and performing different operations in the ETL pipeline. So if we go back to the pipeline, the first step here, taking data in from the source to our raw store, the bronze layer, is basically ingestion. From going from the bronze layer to the silver layer is the transform step, and then based on business logic, we can move on to the gold layer. So that is basically the entire pipeline. So I first generate the random data. Just a second. So I first generate the random data. I ingest that data to my bronze layer. I perform some basic transformations on that silver, on that bronze layer to get to the silver layer, and then finally I create the data warehouse objects and load data into my gold layer. So this load gold method here basically defines the business logic. So if let's say I want to go to this method, in this method we are first reading the data through the silver layer. So you can see I'm using the silver data layer. I then have some business logic here. So let's keep going down. So I'm here. I'm fine. This part here is basically where I am creating the dimension tables. So the professor would have covered dimensions in the course itself during the lectures. So this is basically where I'm creating the dimension tables. So these dimensions are the fact tables and the dimension tables. So those dimension tables are what we are talking about right now. So these are the dimension tables. We then have our fact columns, and we also create our fact table down here. So this is where we are creating the actual fact table in Postgres. There is the pipeline file which we were going over earlier. Finally, to perform business analytics, we want to sample some quick key performance indices. So that's what we are doing here. So we are just querying a KPI table which we created earlier, and we are just sorting it out and returning a result. So to run this pipeline, there is an application too which you can run and then directly query using an API. So I'll be running that next. So I already have Docker running here. I have also included several README files here. So if you go to running guide, you'll find a sample curl query to run the pipeline. You can simply copy it and say go to the terminal, and you can run the curl command directly here. So before we run the curl command, I would also like to show you the Metabase UI. So Metabase is a tool where you can browse your data and also do some basic visualizations on your data. And in the current app setup, it is connected to the Postgres database. Okay, so Metabase is running on port 3000. We'll just quickly go over to our browser and go to localhost 3000. So when you log into Metabase for the first time, it will ask you for some basic details. So you can just put something here, and like any email will do. I'll just put some placeholder email. And for password, you can create your own password. There are some restrictions that you should have a special character and a number. So I'm just using password -1. Once you have that set up, you can fill anything for this. It really doesn't matter. And now you'll be required to connect to your database. You choose Postgres SQL for this application. I'll also include the connection string in one of the README files. Okay, so for for the purposes of this demo, this is the information you need to enter here. So yeah, you can look at the video and use the same information. It should work out. Let's see if we are able to connect. So there we go. We are able to connect to the data warehouse database, which is running on Postgres. And we'll just finish the setup and say take me to Metabase. All right. So right now, if you can see here, we don't have. Okay. So we have our support data warehouse DB visible here, but this database does not have any tables yet as of now. So what we'll do is we'll go back to our terminal and we'll hit this API endpoint. So this end tickets is basically the number of tickets which we are creating, and since the number is 20,000, it will take some time. Let's wait. Yeah, there we go. So it has created all the data. So if you go back to Metabase, the data is still not reflected here. So that is because we need to refresh our data. We'll go to settings, we'll go to admin settings, databases, support DW, and we'll just say sync database schema. So this says that a sync has been triggered. also say rescan field values. Now we go back, exit admin, we go back to our databases, we click on support DW, and here you can see that we basically have visibility over the gold layer. So gold layer is the layer which end users will primarily use to perform any kind of business analytics, ML task, data science tasks. So here you can see that we have our dimension tables, our fact table, and our key performance index compliance table. So this is basically a metric that, let's say, in our demonstration, we are using this metric to uh, track some sort of a business impact. So if we go to our fact support ticket table, we see the dimension keys basically. So ticket key is here, date key is here, customer key is here, and these keys are used to link data back to the dimension tables. This is something which has been covered as part of your course. So you can see the different dimension tables are present. Yeah. So now going back to the fact support ticket table. So we see here that, okay, let's say there was a ticket with ID, an agent assigned to it, and the customer who raised the ticket. We have the created at timestamp and also the resolved at timestamp. Through this, we are computing how much time did it take to resolve that ticket, and also what was the SLA target minutes. So SLA is basically your service level agreement. So your business has promised the customers that whenever they raise a ticket of a certain kind, they will get a resolution within 240 minutes, and they are able to provide that resolution within 54 minutes. So SLA has been met, their agreement which they had committed to has been met. Similarly, if we find some other example, let's see. Yeah, so for this particular ticket the SLA was 120 minutes, but they took 187 minutes to resolve the ticket, hence the SLA was not met. Now, this is our fact table which we have built out of the dimension tables. Next, we will be looking at the KPI table. So here we see that for the year is 2025, month is 11. A particular team, let's say team onboarding, has received tickets which are pertaining to the issue type permissions. They have received a total of 7 tickets and have met the SLA 7 times. So their SLA compliance percentage is 100%. On the other hand, let's say some other team, escalation, has received 6 tickets but has only met SLA for 4 tickets. So they have a 66.67% SLA compliance. So this metric can possibly be used to understand where is the business struggling, or okay, what teams are performing well, what teams are struggling, what kind of issues are there which are more troublesome compared to other issues for a particular team. So let's see here. So for tier 1, the SLA compliance percentage for issue type performance is 97.5, whereas for bug it is 91.76, for login it is 85. So you see, maybe the team tier 1 needs to focus more on login issues, right? We can also use Metabase, this tool that we are using right now, to browse our data to create some basic visualizations. So let's say we want to visualize this data as a bar chart, let's say. You can go here, click on summarize. So summarize is basically a group by operation. So you want to summarize by count, issue type. So the total number of issues for login were 109. So since this data was randomly generated, so it's pretty uniform throughout. But let's see for team. So team, there's still some variation maybe. So 185 for onboarding, 196 for tier 1, and so on. So Metabase also performs some visualizations and analysis on its own. So let's say if you want to look at the KPI table through Metabase's own summarizations. So these are not usually very helpful because of how the data is. So since year is an integer, is a number, they try to fit it here somewhat, but yeah. But you get an idea that you can use Metabase for basic visualizations and browsing your data, right? Okay, so if someone wants to run the pipeline stage by stage, so let's say they want to ingest the data, then wait and look at what has changed, then perform the transform step, and then see what has changed again, and then finally perform the load step into gold. They can do that as well. They can do that as well. So in the code we have different scripts. So let's see here, there's a script for ingest, there's a s- script for transform, and then there's a script for uh, loading into gold. So they can run each of these individually and see the step by step results as well. For the purposes of this demo, I'm not going to go over that.